Okay guys, we're going to pick back up with solving perfect cubes. So we've been factoring, now we're going to solve. I put this in steps for you. So the first step is to factor. Second step, you're going to set your binomial equal to 0 and solve. And then you're going to use the quadratic formula to help you solve your trinomial. So to refresh your memory on the quadratic formula, x equals opposite of b plus or minus square root of b squared minus 4ac, all that over 2a, if you need to refer back to that. So example 4 tells us to solve for x, and when you're solving you should remember that we need to set this equal to 0. So in this case we would subtract our 27 over, so you're going to have x to the third minus 27 equals 0. This creates our difference of cubes, and if you remember from our fundamental theorem of algebra, we should have 3 solutions, 3 zeros, 3 roots. Remember, all those mean the same. So now we're going to factor. Step 1, factor. So we're going to take the cube root of both sides. So the cube root of x to the third would be x. Same sign. Cube root of 27 is 3. So you've created your binomial. Square your first term. Opposite sign, product of your two terms, always a plus, square the last to get 9. And remember that's equal to 0. So step 2 tells you to take your binomial, set that equal to 0 and solve it. So when we do that, we're going to get x equals 3. So there's one of our solutions. It then tells you to use quadratic formula to solve your quadratic. So if you think about this, we've got a is 1, b is 3, c is 9, and we're going to sub that into the quadratic formula. So opposite of b is negative 3 plus or minus the square root of b squared minus 4 times a times c, all that over 2 times a. So that's going to leave us negative 3 plus or minus. So under the radical, you're going to have 9 minus 36, which is negative 27 over 2. So then this can be simplified. This radical can be simplified. So I want you to think about this as being 9 times 3. So we're trying to think of what perfect square is a factor of 27. So when we do that, negative is going to come out as I. Square root of 9 is 3, so that's 3i. We can't take the square root of 3, so that's going to stay under the radical. 2 is your denominator. So here's your other 2 solutions. So again, I'm going to go over that, simplifying that radical, square root of negative 27. You would pull the I out to have square root of 27. Think about that as saying square root of 9 times 3. Square root of 9 is 3, so that would come out, leaving square root of 3 under the radical. So that's what I did right here. Example 5, we've got a GCF that can be factored out first. So that's going to be 2x. So let's take that out first. That's going to leave us with 8x to the third minus 27 equals 0. So we can take the cube root of 8 and we can take the cube root of 27. So I know that this is a difference of cubes. So we're going to have 2x. Let's make the binomial first. Cube root of 8 is 2. Cube root of x to the third is x. We want to keep the same sign. Cube root of 27 is 3. Now we're going to build the binomial. Square your first term, so that's going to be 4x squared. Opposite sign, so that would be plus. Product of these two, so 2x times 3 gives us 6x. Always a plus. Square the last, so 3 squared would give us 9. We should have 4 solutions when we finish. So this time you don't have, the first, or step 2 said set the binomial equal to 0. We also need to set this 2x equal to 0 and solve. So x equals 0. our binomial, we're going to take 2x minus 3, set that equal to 0. We would add 3 and then divide by 2. So there's our second solution. And then we need to do quadratic formula with our trinomial. So a is 4, b is 6, c is 9. So x equals opposite of b plus or minus the square root, b squared minus 4 times a times c, all that over 2 times a. So just be careful there because your a is not 1 anymore. So then we're going to simplify that. So we're going to get, I'm going to have to go down here. So let me see what we get under the radical real quick. So we're going to get negative 108 under the radical. And that's going to be over 8. So then I'm going to try to figure out what perfect square is going to go into 108. Little trick again on the calculator, guys. If we did 108 divided by x, and then you're going to do second graph, I can find all the factors of 108. So I'm looking for the factor that I can take the square root of. So I can take the square root of 36 and 3. So this is like saying square root of 36 times 3. So x equals negative 6 plus or minus. Negative is going to come out as I. Square root of 36 is 6, so that's going to be 6i. Cannot take the square root of 3. All that over 8. So we still can simplify because 2 will go into both of these. So that's going to be 2 will go into that 3 times, plus or minus 2 will go into 6i 3 times, and then 2 will go into 8 4 times. So you have 1, 2, plus or minus creates your other 2 solutions, so for a total of 4 solutions. The last one is the your turn problem. I didn't have room there on the notes, so I'm just going to do it here on this paper. Again, we need to set this equal to 0, so you would add this over to get 2x to the third plus 2,000 equals 0. We have a GCF of 2. So then we have a sum of cubes. So again, that trick there in your calculator, math, we're going to go down to cube root. I'm going to key in 1,000. Which is 10, so we'll build our binomial. Cube root of x to the third is x, keep the sign, cube root of 1,000 is 10. Now make your binomial, square the first, opposite sign, product of the two, always a plus, square the last. So then with this, we don't really worry about this 2 because I can't set 2 equal to 0, so you're really just going to forget about that. We're only solving the ones with x as our variable. So we're going to say x plus 10 equals 0. And that would give us x equals negative 10 for one solution. And then we're going to do quadratic formula here. So a is 1, b is negative 10, c is 100. So x equals opposite of b plus or minus the square root of b squared minus 4 times a times c, all that over 2 times a. So 10 plus or minus the square root of, let's see what that's going to give us. Negative 300 over 2. So let's go ahead and bring the I out first. So if you're struggling with simplifying that radical, maybe this will help you. So then the perfect square that's a factor of 300, that's 100 times 3. Okay, so because we can take the square root of 100. So we're going to say 10 plus or minus square root of 100 is 10, so that's going to come out as 10i. We cannot take the square root of 3, so that stays under the radical, all under 2. And then I can divide both of these by 2, so that'll be 5 plus or minus 5i square root of 3. So here, let's go back. We should have had 3 solutions, so 1, 2, 3.